Math 1332, Chapter 2, Set Theory, Section 2.1, Introduction to Set Theory, Video 5, The Cardinality of Set. Now, you may have heard the word cardinality before, and you may not have. But regardless, it's a really, really simple concept. The cardinality of set A, and I'm speaking generically, I'm not speaking specifically about that set A. First off, the way you write the cardinality of set A. You write cardinality by writing a lowercase n, opening a set of parentheses, putting the name of the set inside the parentheses, and then closing the parentheses. You could read that cardinality of A. In fact, that's how you should read it. Cardinality of A. The cardinality of set A, written like this, is the number of elements in set A. Think of it as a question. Excuse me, set, how many elements do you contain? The answer is the cardinality of that set. You can almost think of it as the size of the set. Some real quick examples. Find the cardinality of each set. Okay? Let's start with set A, this set A, that contains 1, 3, 5, 7, 9, 11. You could say it's the set of odd numbers less than 12. I'm sure there are other ways to describe it, but we'll just go with the roster form. To answer the cardinality of A, you simply have to count how many elements it contains. 1, 2, 3, 4, 5, 6. It's a counter. I contain 6 elements because my cardinality is 6. What about B? Set B, the set of all x's such that x is an element of the whole numbers. Do you remember where the whole numbers start? And x is less than or equal to 5. Sometimes the hardest part about cardinality is knowing what you're counting. In the first example, it was there for me to count, but not in this one. Because set B is written in set builder notation, and we're being asked what's the cardinality, it might benefit us to actually write out the elements of B in roster form. The set of all x's such that x is an element of the whole numbers, which start at 0, by the way, and x is less than or equal to 5. So I'm going to list all the whole numbers that are less than or equal to 5, starting with 0. 0 is less than or equal to 5, as is 1, 2, 3, and 4. But do we include the number 5? Yes, because this inequality reads less than or equal to, and last time I checked, 5 is equal to 5. And so it's less than or equal to 5. Now that we see the elements of B, we can count them. And the cardinality of set B is also 6. What about example C? Hey, it's our set C of U.S. capitals again. Well, assuming you're familiar with U.S. geography, you should know that the United States contains 7. 7. Where did I get 7 from? The United States contains 50 states. I have no idea where I got 7 from. I do want to clarify, though, that when we originally defined C, we said state capitals, because I know some of you would go, well, what about Washington, D.C.? That's a capital. You're correct, but it's not a state capital. So to make it 100% clear, let me put the word state back in here as it originally was. And now it's more well-defined. Well, you can't be more well-defined. You're either well-defined or you're not. We'll just say that this one is. There are 50 U.S. states. Each state has a capital. Therefore, the cardinality of C is 50. Without the word state here, you could argue 51 unless we clarified what we meant by capitals without preceding it by the word state. And D, the empty set. By definition, how many elements does the empty set contain? None. So if I ask it how many elements does it contain, which is equivalent to asking what's the cardinality of the empty set, none. it should be pretty evident that the cardinality of a set is probably a whole number. Because it can be 0, it could be 1, like the last example in the previous video. Remember, the set containing the empty set had 1 element in it. The cardinality of 2, for example, the set of siblings that I have, 2 brothers. 3, 4, 5, 6, 50, or any other whole number I want. Cardinality of the set of the cardinality of the set of grains of sand on the planet Earth. There's a lot of them, but it would be a whole number, because at some point you would reach it, way down the list. It does raise an interesting question, though. What about something like, what is the cardinality of the natural numbers? This is asking how many natural numbers are there. Recall that the natural numbers are 1, 2, 3, 4, and it goes forever. What would you say the cardinality of this set is? 1,000,000? 1,000,000,000? Both of those answers are too small. This set goes beyond both of those numbers. In fact, if you give me any natural number, this will go beyond it. 5 trillion, okay. 5,000,000,001, 5,000,000,002. This never stops. So what can we say the cardinality of the natural numbers is? Well, we could say, well, what's the symbol for something that goes forever without stopping, mathematically speaking? Could we say this? That the cardinality of the natural numbers is infinity? Later on in this chapter, we'll address this question a little bit more in detail. The answer is yes, but there's more to the story than that. We'll talk a little bit more about the size of the natural numbers later in this chapter, and I think later in this section as well. Let me glance at my list of videos. For now we can say infinity, but we'll give a better answer later. Just remember, cardinality is like a question: how many elements do you contain?